Okay, so what we are going to be looking at, what we're going to be looking at now is on our day 4. Let me quickly bring it up. Day 4 content says conditional statements used for decision making in Python. That's what we are going to be looking at. In programming, real life is all about making decisions. And so if we are going to replicate whatever that is in real life into the programs we are writing, there is need also to inculcate that property of being able to make decisions. So even when you are creating objects, which are instances of classes, we have not come to that point. Objects should be able to make decisions. Objects should be able to do some things. And one of the things that they will be able to do may be based on a decision of what may happen. Right. So in every intelligence system, a program, there are times when a decision has to be made, some certain conditions. For instance, if a student's score is above 50, you can maybe say that a person passed the examination, or let's assume now you want to grade people based on their score. So you say if the score of a student is between 40 or is equal to or is greater than equal to 40 but less than 46, you can say grade the student E, and so on and so forth. And at the point you will now say if this student score is equal or greater than, or rather greater than or equal to 70, grade the student A. Okay, so that is the system trying to become intelligent. And the essence of that is so that it should be able to adapt to several conditions that it may meet in real life. So another example is if the weather is sunny, you can now tell your robot to go out or whatever. Otherwise, the robot should not go out to avoid being caught up in the rain. Okay, this type of logic is implemented in Python using conditional statements. And this is what we are going to be looking at. So at the end of this lesson, you should be able to explain what conditional statements are and why they are used. Okay, which I've mentioned. You should understand the syntax and the use of the keywords if, elif, and else statements in Python programming. You should be able to write programs that make decisions based on user inputs. And you should be able to apply nested and multiple conditions effectively. And finally, you should be able to use conditional expressions for concise decision making. So you can write a program that makes the decision. Now, remember that this, the thing that we're learning here is just like acquiring tools in our toolbox in order to be able to implement programs that work, build systems that work, systems that solve problems. Now, for you to be able to apply these skills effectively, you should be able to understand the algorithm guiding whatever that you are doing. All right. Let me, Udo, were you able to let the person in?
So let me check. I did not get the notification.
Please check. I got. Check. Chimezie Naomi is requesting to be admitted. I want to be sure if you were able to let her in. Have you seen it? Have you seen the button?
So no.
Okay, don't worry, let me admit her. Okay, so what I was saying is that all these things that we're learning here are tools that we are acquiring into our toolbox to be able to solve some specific problems that we may find along our way. Okay. So I want you to, the ability to solve that problem is based on your ability to create a step-by-step approach to solving the problem. But these things we are learning are just tools that we can use to solve the problem. Why do I say that? The examples that we've just given, you will notice that you can use any other programming language to solve that same problem. All right. But here you are learning the Python language, trying to be able to grasp whatever it takes for you to implement a solution using Python. But the step-by-step approach towards implementing that solution depends on your idea of formulating a solution to any problem. So why I'm saying this is that you need to think in algorithm, think think solutions, not just think programming. All right. When you're able to think solution, you can even sketch how a problem should be solved. Sketch it. Now, if you're able to sketch it, maybe using flow diagram or whatever, then any other person or even you can use a programming language to implement that solution. So two things we are doing here: one, collecting skills; two, having an understanding and a way to be able to build a solution to any problem that we'll see around. And I would want us to, maybe by the end of this class, generate a problem. In fact, when we are teaching this thing, I want you guys to be, if you're having your pen and paper, you can write out a problem that you will give us to solve, so that that problem will be the assignment for each and every one of you to do. So I want you to maybe use, as we are going through this class now, you can write a problem, a fictitious problem that you want us to implement, or rather to solve, using the skills that we are grabbing here at this point in time. So the first question that we have here is, what are conditional statements? Now, when you look at this, you discover that the keyword here is conditional, all right? The keyword here is conditional. Okay, conditional statements are statements that allow a program to execute certain blocks of code only when specific conditions are met. Okay, so execute certain blocks, not all blocks of code, only when specific. These are the keywords that you have to bear in mind. These are statements that you have written to be able to execute some parts of the code, specific parts of the code, only when specific conditions are met or are true. So in order to be able to implement this, Python uses three conditional keywords, as the case may be. So the first keyword is the if keyword. The second is else if, which is written elif for short. And then the third is else. Okay. Now, for example, let's say we store the value 18 to the variable age, and we can now write a simple conditional statement that says, if age is equal or greater than, or rather is greater than or equal to 18, it says you are an adult or you are eligible to vote. Now, what does this mean? We have two operators here. We have two operators. What it's telling us is that there are two conditions that may be made. may be met before you print this particular line of code. And one is, it is either that the age of the person is greater than 18 or is equal to 18. Now, if we are looking at, if we are actually taking greater than, if we don't want to use this, we can just say if age is greater than 17. All right. But we may not want to use it that way, because age may, especially when the age data type is not completely an integer. We discover that there are also some numbers that may fall in between 17 and 18. Okay, that's when age is not of the data type integer. Okay, so if we have age to be float, you discover that we can have 17.5. So at that moment, you may not be able to say age is greater than 17, because it may not really be up to 18 for somebody to be eligible to vote. So for this, there is need for us to understand the type that the age is of. So at this point, we are assuming that age is of the type integer. So we say if age is greater than or equal to 18, then you say you are eligible to vote. All right. Sorry. Now, the expression age is greater than or equal to this is the condition. This is the condition that the thing will look at before it performs the operation. So if that condition evaluates to true, then that block of code will be executed. Then if it evaluates to false, for instance, if that age is less than 18, then it's not going to work. All right. Now let me quickly push up my VS Code. I want to believe you are seeing it. It's too big. Okay, let me just open up the for.py. All right, I have this. Okay, you say if, first of all, you set the age variable to be 18, or let me quickly be using the input variable so that the stuff will look a bit dynamic. All right, so I say all right. Right. Okay, so from what you are seeing here, it says if age is greater than or equal to 18, print you are eligible to vote. So you just discover that the moment I try to run this program, what is going to happen is that it prompts up the age prompt, allowing me to put my age. So let's assume that I put, let's just say 18. What is going to happen is that it's going to print this. So as I put 18 here and I press enter, it says you are eligible to vote. Yes, you are eligible to vote. Now, if I run the program again and I just put something like 16 and I press enter, you discover that the system broke out and there was nothing else to show. Now, what does that tell us? Now we can now, at this point in time, put another keyword, which is else. Okay. So the moment you put the else keyword, you can now say what happens if the other line is not showing what, or rather, if the first condition does not evaluate to truth. Okay. Okay, so instead of printing this, I now said if the age, if this condition does not evaluate to true, what you are going to say is you are not of age. All right, so print this and enter 12 here and press enter. So it shows us you are not of age, right? So at this point in time, we have implemented the age, sorry, the if keyword, and then we have implemented the else keyword. Now, if you look at this carefully, I hope you are seeing my screen clearly. So if you look at this carefully, you will notice that for each line of statement, I ended it with a colon. All right. Instead of maybe if this were to be other languages, you can put this like this. Now, it's going to still work in Python this way, but in other languages, you don't just end it here. You are going to replace this with something like curly brace, not something like it's curly brace. All right. But in Python, we use this. So if this were to be PHP, this same code is going to look something like if age is greater than or equal to so it's going to look something like this, and then you are going to type else. All right. So if this were to be PHP, so you now discover that this thing introduce another complexity in the work, which Python does not want to show to anyone. All right. So this is what we have at this point in time. Let me see somebody. All right. So if age were to be 16, there would be no output because the condition will be false. All right. So, but I've already entered what is going to happen if you don't want that to be the case. All right. So looking at this, the simplest conditional statement is the if statement, which has this as the syntax. Okay, so if condition statement, the colon marks the beginning of the indented block to execute if the condition is true. All right, so you see an example. If temperature is greater than 25, print the day is hot, and so on and so forth. Now let's quickly look at the if else statement, and I've immediately implemented this. Okay, we've implemented this. So this is the syntax for the if else statement. This is the syntax. It says if condition statement, the first statement, this statement will execute if this condition is true, which is what I've implemented. And if it is not true, then this statement will execute. And one thing about this is that the moment the first statement executes, as you are going through the ladder of if else, the moment one of the condition becomes true, every other thing in that block of statements or block of codes will no longer execute. And if you look at this example, this is what I just typed. If age is equals to 18, print you are eligible to vote, else print, excuse me, you are not eligible to vote. Okay. The if, elif, else ladder. Now, when you now want to talk about multiple conditions, like I just mentioned concerning maybe students grading, when you want to, when you don't want to do, when you want to implement multiple conditions, that is where the elif statement comes in, depending on all the conditions that you are going to meet in real life, right? So if you are writing something like PHP, there is also a switch statement. that you can use to implement this same condition. So we're going to look at it. We're going to look at an example of this statement. Let me go back to the coding environment. Now, I want to, so instead of putting this, I'm going to change it to, let me quickly copy and comment this out. So instead of talking about this, I may now say student score. I say enter the score, enter your score. This is what you want to use to check what you have. So let's assume. So we can now start writing the program. So we want to know what somebody scored or what somebody has, or rather, yeah, what somebody has. Now, it's a print. If the score is less than, if student score is less than 40, what are we going to print now? It means that the student has F, right? All right, are we together? So if the student score, if a student score is greater than or equal to 40, all right, and score is less than or equal to 45, that guy is going to score what? Print E. And I say elif, if score is greater than, tell me what to write now.
So. Sorry.
Am I right? I want to print D at this point in time. Still say else elif score is greater than or equal to 50. And that same score is less than 60. We ask the system to print C for us. And say elif, if score is greater than or equal to 60, and it's less than 70. Print B for us. So else, what are we going to put here? Print A. Okay, this is the application will run it. It says enter your score. I said my score is 39. Press enter. Said F. Play the game again. Enter your score. My score is 89. What did he say? There's a problem here. Okay, let me even print between this and this. Let me say 43. E. $53. C. 65. B. Okay, it's working. I don't know what happened to it before. So it's working. So you notice that this elif ladder is working. Now, if you put else if here, it will still work. What's happening? It's supposed to still work if you put that, but you run it this way. Okay. Okay. So apart from this, you will have the nested if. And in the nested if statements, you discover that there are certain things, or rather there are certain conditions that you may have to enter if the first condition becomes true. Now let's look at this example. It says age is equal to 20. Now, another thing is, you see now another condition. The first condition is that age is equal to 20. And the second condition is whether the user has voter's card. All right. So you discover that in real life, although your age is, you are up to the age, and if you don't have voter's card, then you cannot vote. That's the reality. So the point I'm trying to make here is that sometimes the first logic does not work as it were in real life. There may be other factors you may have to consider to be able to perform an action that is acceptable. So if we look at these codes now, it says if age is greater than or equal to 18, that means we can consider if that person can vote. Are you getting it? So we can enter into this place. But if that person is less than this, then we say you are too young to vote. So we are not considering even whether you have voter's card or not. So you are too young to vote. So please go home, or you can just observe. Now, among those that have that are of age to vote, you now check if has voter's card. That means if this thing is true, if the person has voter's card, okay. If he has voter's card, then he can vote. Or if he does not have voter card, you can now tell him, or rather output a different statement that says, excuse me, please go and obtain your voter's card. Okay. So you now see a scenario where you can implement this. Now, what is the output if the guy's age is 20? It says you can vote. And that is if he has voter's card, because this is also true. Right. Who wants to say something? Somebody wants to say something, right? Okay, let's just look at that same. So that same thing. So I want to say age is set to, the age is set to whatever the user enters, all right? The age is set to whatever the user enters. Now, then has voter's card, is set to, let's set it to true. Let's set it to true by default. Okay. And then we'll write the program. We say if age is greater than equal to 18, what are we going to do? Enter into this place and do some things. Now, if it is not like that, we say print you are not of age. So it prints you are not of age. I'm being deliberate to put this in a single quote to let you know that it is still working. Now, if this one is like this, we can now add another if else statement inside of it. Say if has voter's card, that's if this guy has voter's card, you will now say print, you can now vote. Otherwise, if he doesn't have voter's card, you can tell him please go and get your voter's card. Right. Please go and get your voter's card. So before we do that, let's comment this out so I can only run this one. So if I try to run, it says enter your age. Now I say that my age is 12. Press enter. It says you are not of age. Okay. So can run it again. What's your age? I say my age is 21. Press enter. It says you can now vote. Now, if I come to this place and change that, I do not have voter's card. I do not have voter's card. So running again, what's your age? Say I'm 23 now. It says, please go and get your voter's card. If you're 23 years old and you don't have voter's card, you need to go and get it. That is what it means. Okay, so that is it for nested elif statement. That is it for nested statements like this. I don't know if anybody has any question, because whatever that is here, I have covered it already. whatever that is here, the combination of using this and or and not, I've touched it. But let's see if we can have an example that I did not touch. Okay, look at this example. The example using or. It says day equals Saturday. You now say if day is equal to Saturday, or rather if day is equal to Saturday, that means if this variable is having the value of Saturday in it, or day is equal to Sunday, what it means is that it is weekend. Okay, because we regard Saturday and Sunday as weekend, depending. It's raining is false. So if not is raining, it means you can go out. That means if it is not raining, right? If not is raining, that means if it is not raining, that's what it means. It means you can go out. And before we close for today, there is one thing that is known as ternary operator in Python. And this is the condition where you can use shorthand in writing your if-else statements in one line. Now, notice that it is not if, elif, else statement. It is if, else statement. Okay. Now, what happens is that the first thing that is supposed to evaluate to true comes before the if condition. And then when you put the if condition, you put the else immediately on one line, and it works that way. Now, let's look at this example. This if somebody's age is this, all right? Somebody's age is set to 18. Now, instead of saying if age is 18, print you are an adult, or print you are a minor. So instead of that, print whatever, you first of all assign this thing, this string before, and then after the entire stuff, you assign the other string that should be printed. All right. So this is an adult. If you are an adult, if your age is greater than, this is how it's supposed to be read. It says you are an adult if your age is greater than or equal to 18. If not, you are a minor automatically. Now, for us to do this, you can now set whatever that is supposed to come out of this place as a variable, and then print that variable. Okay. Now you need to code this. You need to try to code this. As I'm giving you all this PDF, please, I want you to try to code it yourself. Don't copy it and paste. Try to code it yourself. All right. Okay, let's just say I want to use something else. Let me just use age. So let's just say that age is equal to whatever the user enters. Whatever the user enters, right? What is happening here? Okay. Now I'm being deliberate in putting this. I'm being very deliberate. Okay. Where is the syntax error coming from? Syntax error coming from. Sorry, I don't know where this error is coming from. Let me just cut off this and it's showing me error. I don't know what should warrant the error. Please look and see if okay, let me. Age is set to whatever input the user gives us. Says, what is your age? Okay. So this is what is your age. Then the next thing now, what was I trying to replicate? So I now write maybe status like the example showed. Okay, status is set to that you are an adult, you are. You are an adult if age is greater than or equal to 18, right? Else, you say you are a minor, right? So now say print the status of the person. Okay, so what we have here is this: if whatever the user puts here is equal to 18 or greater than 18, is going to output you are an adult. Now this one evaluates to the whatever that is shown on the left-hand side is the output when this condition is true, and whatever that evaluates after the else statement is going to be the output when the condition here is actually false. So we now print the status. So it says, what is your age? My age is 24. I press enter. Is now printing status. What's the matter here?
Your status is in quotation mark.
Ah, yeah, very good. Thank you very much. Okay, I'm printing it as a string instead of as a variable. So print, this is 24, press enter. It says you are an adult, right? Now, if another instance of it shows that somebody is 12, I press enter, it says you are a minor. So sometimes it is necessary for, if you are giving, if you have a simple condition to test, instead of testing it in different lines of code, it is easier and more economical to implement it this way. All right. I know you may not understand what I mean by being economical to implement it this way. Have you guys done a course on data structures and algorithm? I think it's one of your years. It's one of the courses that you will do in your year 3. Okay. So why I said that it is economical to do it this way is that the one run of a program has memory efficient memory. It has some. What do I mean now? What do I mean now? Let me just use the word. Let me just use the word that there's a kind of space it will take in memory to be able to process one. Let me just use the word one line of code. Now, if your codes have too many lines, it means that although your system will work, but the time complexity will increase. What I mean is that if it takes, okay, this same code now, this same thing that appeared in one line, if I'm to write it, I'm supposed to write if age. Let me just say if age is equal to 18. Okay. This thing is one line of code. Do you understand? If age is set to 18, this thing is one line of code. All right. This is one line of code. You say print, blah, blah, blah. Otherwise, another line of code, print, blah, blah, blah. Do you understand? Now, I've compressed this thing in one statement, in one line of code. So if it takes these things, if it takes this thing now, okay, because we are going to include the print. If it takes this thing 2 seconds to implement, it means now that it's going to take this one how many seconds to implement? 5 seconds. Sorry, 4 seconds. Are you with me? Now, what it means is that your code working is not just the thing that you will also talk about. You also talk about the space that your code takes in memory, all right? And the time it takes for your code to respond. So when you are studying analysis of data structures, these two things are very important. In fact, they are the indices of assessment. Number one is the time complexity, and number two is memory stuff, space complexity. That's the amount of space that program takes in memory. Okay, so if you do it this way, it will work. If you do it this way, it will work. But for you to be more efficient, it is good you do it this way. You learn how to do it this way. Okay, it is necessary. I will start now to teach you that so that it will become part of you in no distant time to write codes that are efficient, not just code that work. All right. So look at the practical applications of these things. Temperature checker. This is a practical application. Number two, even or odd number checker. This is another practical application. Number three, this is the one that I used yesterday. Simple login system. If username equal admin and password this, okay, this another place you can use it. Now, but before we wrap up this, there are things that we need to look at here, common errors. Number one is indentation error. I made mention of this, I think, in our first class. Okay, indentation is very critical in this course. Indentation is very critical, right? It is necessary for you to use uniform indentation. Otherwise, you may be looking out for indentation error, but you'll notice that the moment you open a line of code, for instance, the intelligent coding environment you have will automatically do the indentation for you. So For instance, I say if true. The moment I put this colon, telling it that I'm trying to look at what happens if true. Okay, if I push enter, it automatically indents it for me here. Now, if I don't do that and I come to this place, it's already telling me that there's an error here because there is no indentation. The expected indented, this thing is expecting indented block. Why? Because of this colon that I placed here. Okay, so this is one of the common errors you may face trying to implement what we have just learned here. Okay. Number 2, always ensure conditions are Boolean expressions. What do we mean by this? Ensure that the condition that you are evaluating will either evaluate to true or false. All right. So if not, you may be writing something and you don't know why it is not working. Okay. Now, avoid writing deeply nested conditions. Use elif or combine with logical operators for clarity. You know, when you're also doing data structures and algorithm, you will just discover that although numerous elif statements will work, but the time complexity will increase. They have moved that course to computer science because I would have loved us to look at the practical implications of that. Okay, the more you next if statement inside of another if statement, the deeper the nesting, the more time it will take the system to process that. Possibly it may not be, or rather when you implement your work, it may come up fast, but that's the response of that system on your development environment may not be the same when you have deployed the system. Okay, so the instruction here is for you to avoid writing deeply nested conditions. If it is possible by you, avoid it. Check another algorithm, another way to implement whatever you want to implement to perform the same function instead of writing a very deeply nested condition. All right. Now we have, there's no hands-on exercise here. So I want to hear from you what you think, an example that you think that we can undertake in the course of this. Yes, can I hear you now? Questions, comments, and suggestions. Questions, comments, and suggestions.